We actually have another nice one. This one's actually also asking us about pH, and this is also from Gina, took it from Gina's question. This is from DBE 2018, and this is a November paper. And this one says sulfuric acid again. Can you guys see the trend of all the acids and bases that they're using? If you don't know that sulfuric acid is H2SO4 by now, no guys. You have to know that sulfuric acid is H2SO4, that it ionizes completely to form SO4 2-. It will form H3 plus, H3O plus in water by donating an H plus. It's exactly the same thing for every question. So in this case, what they've given us, they say that sulfuric acid is a strong acid. Now we already know a strong acid. What is meant by strong acid? It dissociates completely, right? And who tells us this? If we look at the Lowry-Brownstead theory, and if we look at the Arenas' theory, they can confirm this with us. Sulfuric acid is a strong acid. Sulfuric acid is a strong acid present in acid rain. Then they've given us a reaction for sulfuric acid. Let me just write it down. They've given us the 2 steps in which it ionizes. We remember we've got H2SO4. If you put that in water, it'll dissociate. Now remember guys, we've actually done this before. This will become HSO4- plus H3O plus. That's the first ionization of sulfuric acid. Then we take this product. I'm going to have HSO4- plus H2O. What does that become? This one will lose the H by donating it to the water, and the water will accept it. I'm going to have SO4 2- plus H3O plus. So that's the reaction they've given us here. And then the first step says, number A says, okay, it says we must define an acid in terms of the Lowry-Brownstead theory. So again, Lowry-Brownstead theory says an acid is a proton donor. We've done this. I'm just going to write done. I don't want to waste time because this one is actually very easy. And then number B says we must write down the formula for the conjugate base of the H3O. Now, Jessica was the first person to show us how to find the conjugate acids and the conjugate bases. I'm just going to go through the first one. H2SO4 is an acid because it donates. H2O is a base because it will accept. It will accept. For HSO4 to become H2SO4, it will have to accept. And for H3O plus to become water, it'll have to donate. I don't really have space there, so I'm just going to write, let me write it like this. Let me take the bottom part off. Take the bottom part off. Conjugate. And I have a conjugate. I have another conjugate there. So now, if what accepts, it is a base. And what donates, it is an acid. There we are. So I'm just going to do that. Jessica asked us to identify conjugates. We've already answered that one. And then this one says, the next question, let's name that number C, says define the hydrolysis. Define the hydrolysis of a salt. Now, remember when we talk about different procedures, they said, name the procedure with the image or with the picture shown here. Remember I told you it was a burette and what. And that procedure, when we neutralize a base with an acid in the presence of an indicator, we call it titration. And I remember what I said, they can either ask you what is titration, then you'll say the vice versa, when we neutralize a base with an acid in the presence of an indicator, or they can give you the image and say, what do we call this process? Then you'll have to say titration. In this case, they say define the hydrolysis of a salt, which also means it's something to do with in terms of a reaction, the same way. So in this case, if we have to define the hydrolysis of a salt, this is when a salt reacts with water. A salt reacts with water. I actually remember seeing a question like this in one of the other questions that the children asked, and then I think it said ammonium pellets, and it was underlined, and it said reacts with water, and then the question said, what do we call that process? If a salt reacts with water, it's hydrolysis. So they can either give it to you either or, the easy way, or try to spice it around by actually underlining a word. So now we have here, we actually have another question here. We have number D. Here they want us to calculate the pH. They're telling us that we need to calculate the concentration. Concentration. We need to calculate the concentration of the hydronium ions in the water, and this is if the pH is 5. What I always tell my kids, write your pH formula on the side. The minute you have the pH formula, it'll guide you to what you have and what you don't have. So in this case, let's see what we have and what we don't have. We must calculate the pH of the hydronium ions in the water if your pH is 5. But now, here's my formula for pH, so it means I need to work the other way around. If this is my formula, is equal to negative log, I'm going to show you, I think I know 2 ways of actually explaining this if you don't get it. My pH is 5. I've got negative log the concentration of H3O+. That's what I'm looking for. But now, remember what I always say. If you want to make something the subject of the formula, you divide both sides with what is irritating what you're looking for. In this case, when we're talking about logarithms or when we're doing logs, we don't do that. One way of doing it is this one. I'm just going to make a dot there. Well, one way of doing it, remember in school when we have y is equal to log base 10 of x, you take your 10, you replace it with a y, and that is then equal to your x. That's the first one. Or another one that you can actually use, if you have the concentration of H3O+, I think this is the easiest one. You just put a 10 to the exponent pH. So you write it exactly like this, and your pH then becomes an exponent. And then you can even write it and spice it up and just write 1 times 10 to the negative pH, and then you just substitute your pH. So in this case, this is what I'm getting. So I'm going to take this method, which is, I feel like is the easiest. So I'm looking for the concentration of H3O+, right? I write 10 to the negative pH. What is my value of pH? They told me that my pH is 5. So I'm going to have 10 to the negative 5. And I'm going to try spice things up a little bit and write H3O+. It's just so that you know where everything is coming from. 1 times 10 to the negative 5. And this is not incorrect. You can choose, you can write either of these ones. It will still, because 1 times, this is exactly the same thing. So then this question actually wanted us to then work vice versa. So remember, initially in the other questions, they wanted us to calculate the pH when we are given the concentration. In this case, they've given us the pH, but they want us to find the concentration. Do not make a mistake. Let me erase this one. Do not make the mistake to divide logarithms. I wonder what it will give you on a calculator. It will probably say error. Let me use green. If you have 5 minus log concentration of H3O+, you cannot divide both sides by negative log. Please do not do this. We don't do that. Unfortunately, you have to use this method and procedure. And if I was you guys, I would also make a nice bubble around my notes, make a special star there or write important so that you actually know that this is something that you need to remember. Because I just like spicing up the question papers.